Hi everyone! The given research is devoted to the development of items normalization technology for e-commerce marketplaces. Our team represents National Technical University Kharkiv Polytechnic Institute, two departments, Software Engineering, Management Information Technology, and Intelligent Computer Systems. We are going to discuss the issues of e-marketplaces, items matching problem, and items normalization as a way to improve the performance of recommender systems. Our experiment deals with knapsack data normalization. E-commerce positions in the global economy keep on strengthening. As the number of sellers and items being sold on e-marketplaces is growing, the volume of data stored and processed by e-commerce information systems is increasing drastically. The overwhelming amount of available items makes buyers confused. That's why the goal of recommender systems is to improve users' experience and encourage more buying transactions. Today, recommender systems try to encounter many heterogeneous factors while advising specific items to a buyer, like ratings, user estimates, and so on. But still, we can often see that the result of our search is not always close to what we actually need, due to a huge number of items and their incomplete and inaccurate descriptions that can be hardly analyzed by collaborative filtering and search algorithms. Let's consider an example of two knapsacks description on the Hervis Sports online store, which is originally in German language. We can see that these two items have different attributes to describe the same class of products, and the values of the attributes may be presented in different form. For example, here size and volume have different formats and values. The first knapsack has volume followed by liter and the second followed by small letter L. Such arbitrary form of the item description stored by the e-commerce system sophisticates the processing of this data. That's why in this work we suggest the technology of items normalization that should improve search, clustering, filtering, and other procedures of the e-commerce systems. Here is an example of duty knapsack description gathered by the web crawler. It's been parsed and the attributes together with their values have been stored in the JSON format. The goal is to create a unified representation of an item that is used by the system internally, while the view for a user remains unchanged. So, item normalization has several steps. First, the data on items should be collected from the e-marketplaces by the web crawler. Then it should be parsed and stored in the JSON format. The data consists of extracted attributes and their values. The next steps are parallel translation and building of Thesaurus. Normalization implies the substitution of different attribute names by a unified name and presenting attribute values in the unified format. The normalized data is stored in the database and is passed to the recommender system. Our approach of item normalization is based on the idea of a pattern creation for each attribute of the product. Attribute pattern consists of the normalized form of its title and value. The normalized value in its turn includes normalized value format and unit of measurement in general case. Then item descriptions can be transformed in a way to match this pattern. So, if size is called in different ways in the description, like size, dimensions, dimension, etc., it will be substituted by size in the normalized view. And if the values are given in different measurement units and are written differently, they all will be translated into a unified view, for example, centimeters. The experiment data pipeline includes data gathering, parsing, translation, attributes and their values extraction, forming Thesaurus, and finally, normalization according to a template. The obtained JSON results are passed to a recommender system. We have collected data about 141 knapsacks from Hervis Sports online shop and stored them in JSON format. The site is in German, that's why to get the unified model, we've made a parallel translation of the German file into English and got two identical datasets. Then we have extracted all attributes that are met in the collected dataset. The frequency of each attribute's title is shown in the table. Last column contains the number of different formats of the values of a specific attribute. So, for example, we have found 13 ways of how weight value had been presented in the description. While initially we had 24 names of attributes, Thesaurus allowed us to reduce this number to 16. For example, several possible variants of size naming have been substituted by the pattern name size. The data structure of the original dataset is presented on this slide. Each attribute has German and English translations. We've got 16 normalized attributes that are in black. Each attribute's title has multiple possible variants, all normalized to the defined pattern, title marked in blue. If we find a new attribute, we'll try to assign it to existing classes of attributes. If no class suits, we will create a new class for it, so this structure can be extended. Then, moving forward to the values of attributes, we see that they can be given in different formats as well. For example, we have 16 ways of size representation. All of them have been transformed in the unified form. The values before and after normalization are shown on this slide. We could normalize 133 item descriptions out of 141 initial items. The error cases include those items which under size attribute had the values like volume 22 liters and so on, which doesn't match any of the existing patterns of size, thus couldn't be replaced. We have several open questions in the given research. First, we need to check whether the developed structure of attribute classes is complete and will work for any other e-marketplace that sells knapsacks. Second, we need to update the developed structure taking into account the semantical meaning and frequency of certain terms that denote attribute titles in different languages. We are planning to test the performance of clustering and collaborative filtering algorithms that take as an input initial and normalized data, and would like to go ahead and apply the developed technology in a web size localization problem. Thank you for your attention.